guys, today we're looking at geometric sequences. A geometric sequence is an arithmetic or is a sequence with a starting value of a sub 1 and a common ratio of r. So to figure out if it's a geometric sequence, you have to be multiplying by the same number each time. Okay, it's called the common ratio, what you multiply by. So we say what a sub 1 is, and then r is our common ratio. So this is kind of like arithmetic sequences, but slightly different formula. And then here we have our explicit formula, which remember is good for finding the 100th term. Instead of having to extend the sequence out, we got a shortcut. And then r is what we multiply by. Okay, so make sure you got that. First example, write an explicit formula, okay? So, what's a sub 1? A sub 1 is 2. Look at the pattern. How do we get from 2 to 4, 4 to 8? We're multiplying by 2. So this is r. And then we just plug in what a sub 1 is and r. And there we go. There's our explicit formula. Okay, identifying a geometric sequence. Remember, you have to be multiplying by the same number each time. How do we get from 3 to 6, 6 to 12, 12 to 24, 24 to 48? We are actually multiplying by 2. So we are at, yes, it's geometric, r equals 2. Okay, then, next one, how do we get from 3 to 6? Well, that's times 2. 6 to 9, that's not multiplying by 2. So we can just stop and write no, there is no common ratio. Okay. Analyzing geometric sequence. Find the indicated term of the sequence. So the first one, find the 10th term of the sequence. Remember, you got to use the explicit formula for that. So what's the first term? What's a sub 1? A sub 1 is 4. And then how do we get from 4 to 12, 12 to 36? Times 3. If you're not sure, to find r, you take second term divided by first. And that'll tell you what r is. So then we plug it in. 4 times 3 to the n minus 1 power. Well, that's the explicit formula. We're not done. We need to find the 10th term. So n equals 10. Okay, let's see what that is. It's 78,732. Okay, this is the most challenging one. We're going to use this, use for problems 12 through 13. Okay, so identify what we know. We're going to use the explicit formula. We know this is the first term. This is a sub 1. This is a sub 2, a sub 3, and a sub 4. Okay, so we know that the a sub 4 equals 54 when n equals 4. And we know that a sub 1 equals 2. So we're going to plug this in. This is going to be a sub n actually. So we're going to write 54 equals because we don't know what r is. That's what we're going to try to find here, guys. We're going to try to find what r is. Well, we know the fourth term, we know the first term, and if we know that the fourth term is 54, then n would have to be 4. So, plug in what we know. We don't know what r is. We know n is 4. Okay, from here, solve for r. So we're going to divide by 2. Half of 54 is 27. Then, what's the cube root of 27? Well, that would be 3. Now, 2 times 3, we're just going to extend out the pattern. That's all I'm doing here. 2 times 3 is 6. 6 times 3 is 18. And then 18 times 3 would give me 54. So that's how we do it. You have to plug in what you know and solve for r. So like I said, that's the most challenging one. Hang in there. You got this. Okay, geometric means, say we don't know what the middle term is, we just take the square root of x times y. Say this is x and this is y. So this would be 144. Square root of 144 is 12. So this is the missing term. Okay, that's it for geometric sequences.